All right, all my peoples. You better believe that this thing right here, a graph like this, is on tomorrow's test, where you have to be able to read the wavelength. This one's 2 to 10, so that's an 8 centimeter wavelength. And the amplitude, and then be able to figure out either its frequency or its velocity from the numbers given here. And if you can't do that, go back and look at one of the videos or other reviews that are already in your stream. Here is the review that I gave you. I'm going to go over this, and there'll be some other questions at the end. A wave is moving first. V equals lambda f. A wave is moving through air. The wave has a wavelength of 2.22 meters and a velocity of 614 meters per second. What is the frequency? All right, it's 614 divided by 2.22, 276.6 hertz. A wave is moving through air. The wave has a wavelength of 1.65 meters, frequency of 582 hertz. What is the velocity? 1.65 times 582, 960.3 meters per second is the velocity. A wave is moving through air. The wave has a wavelength of 1.65 meters, a frequency of 212 hertz. What is the velocity? All right, again, 1.65 times 212, 349.8 meters per second. That would just be some hot air it was moving through. What is the index of refraction of a medium if light travels this fast through it? N is equal to C over V. The index of refraction is equal to C divided by the velocity, 2.1 times 10 to the 8th. We know that C is 3.0 times 10 to the 8th, so 3 EE8 divided by 2.1 EE8. 1.42 or 1.43 is the N for that, the index of reflection. With what velocity does light travel through a medium with an index of reflection of 2.88? N is equal to C over V. 2.88 equals 3 times 10 to the 8th, that's what C is, over V. What's that velocity? We'll just swap those two. And we'll say 3 EE8 divided by 2.88. And let's change that to scientific notation. 1.04 times 10 to the 8th meters per second. What is Snell's law? N1V1 equals N2V2. And basically, it also is N1 sine theta I equals N2 sine theta R. It says that light goes at different speeds through different velocities. That's what this says. And this says that when light bends, it bends when it hits a new medium according to the density of the other medium, and we can predict its angle. Let's try this. What is the index of refraction of a refractive medium if the angle of incidence is 40 and angle of refraction is 29? All right, this says in air. Air has an N of 1. That's on your tables, and you also just need to know it. N1 sine theta, N2 sine theta. So the N1 is air for 1. Sine of 40 equals N2 times the sine of 29. We have to solve for N2. Basically, it's the sine of 40 divided by the sine of 29. All right. 4D is 4D sine divided by 29 sine equals 1.32. All right, this one's a little bit more. What frequency would be heard? Okay. The frequency detected is equal to the frequency sent times the velocity minus velocity of the detector over the velocity minus velocity of the sender. Okay? So, a car is coming towards you at 40 meters per second. So its velocity is 40. You are still, your velocity is 0. The speed of sound is 333 meters per second. No problem. 333, 333. And since the car is blowing its horn and coming towards you, here's the car. It's blowing its horn. Its velocity is in the same direction of the velocity of the sound that you're hearing. So it's 40, so this is minus 40. It's not negative 40. So 333 divided by 333 minus 40 over, the sound was 500 hertz. 500, so 500. Here, let's find out our fraction first. 333 divided by, parentheses, 333 minus 40, close parentheses, equals. So this whole fraction is 1.1365 times 500. You would hear 568 hertz. And yep, that's right. You know that the car would have a higher pitch if it was coming towards you. What is meant by potential difference? What is another name for it? The other name is voltage. And potential difference is two different areas and their capacity for electrons or their attractiveness to electrons. You may have a chemical on this side of the battery that is short on electrons and a chemical on the other side of the battery that has way too many electrons or wants to get rid of electrons. So this part of the battery, these two parts of that battery would have a voltage or a potential difference. An electrical device with a resistance of 3 amps will allow a current of 4 amps to flow through it if the voltage drop of blank volts is impressed. V equals IR. 4 is our amperage. 3 ohms is our resistance, so the volts would have to be 12 volts. 12 is equal to 3 times 4. When a voltage of 120 volts is impressed across an electric heater, a current of 10 amps will flow. If the heater's resistance is blank ohms, it's going to have to be, let's see, 12. Is that right? 10 times 12 is 120. Yep, 12 ohms. Draw a coil with a current running through the wire. Show the magnetic field. Here is, I'm going to draw this coil like a solenoid, like the one you wrapped around the nail. If the current goes through the wire, you will get a magnetic field that runs through the middle of the coil. And it will have a north end and a south end. How do magnets produce electricity? Why are coils used? A magnetic field a magnetic field being moved past an electron will make it move. Why are coils used? So we can put a lot of the electrons in the path of the magnet at the same time. Surface area is a good answer for this. Why are coils used? Surface area. You're covering more surface with the same motion of your magnet. Explain how your motor from classwork, why did it spin? All right. You had a coil, a flat coil, and when the current ran through it, it made a magnetic field. Now, if you had a magnet down here with the same magnet, then it has to spin to get away from it. Why didn't it stop? Because when this thing flipped over, you had a piece of rubber here that cut off the connection. Why didn't it stop? The connection was cut off. There was no electricity when the south side of the magnet would have got around. Copy and solve the diagrams from the video. Here they are. Diagram number 1 is 120 volts, is running six Christmas tree bulbs. Each one of these is going to have 400 ohms of resistance. What is the current in the wire here and here? And what is the voltage across each bulb? All right. First thing, V equals IR. 120 volts equals I times, well, let's add up the R. 1, 2, 3, 4, 5, 6 times 400. 2,400 ohms of resistance. We have to add up these resistors because they're all in a series. So to solve for I, we'd have 120 divided by 2,400, which will give us 0.05. 0.05 amps. So it'd be 0.05 amps here and here. It doesn't matter. Now, what is the voltage? Well, you could just do V equals IR here. Or you could say, well, all these 6 are splitting the voltage. Let's just do it one at a time. V is equal to IR. The voltage is equal to the amperage, 0.05, times the resistance, 400. 0.05 times 400 gives a voltage of 20. So there's 20 volts everywhere, and all 6 of those add up to 120. Here's the last one. 120 volts. And this circuit will have two 200 ohm bulbs here and two 300 ohm bulbs there. Tell me the current here, here, and here. Then tell me the voltage. Just right there. All right? First thing, these are in parallel. All right? These are in parallel. So those guys don't even know those top bulbs are up there. So we can just do this bottom one separately. 120 volts. 120 volts is equal to some current, and the resistance is 400. So we end up with 120 divided by 400 ohms. .3 amps. Right? Now, these bulbs right here on top, they don't care about those bulbs. They don't even know they're there. So we have 120 volts, and on this circuit, there's 600 ohms. So V equals IR. You have 120 volts. What current with a total of 600 ohms? Right? Okay. 120 divided by 600. 0.2 amps. So if you have 0.3 amps going through this circuit right here and going through the wire there, and then this other circuit has 0.2 amps, then you have 0.5 amps of current right there. That's a parallel circuit. Last thing, what is the voltage right there? All right, V equals IR. The current right here is 0.2 amps. So V equals 0.2 times 300. 0.2 times 300 equals 60 volts. All right, there you go. Good luck.